Well, you got it set today. I figured it out today. Well, I sat there and I was like, wait. He's just going to move me. All right, I'll do that. All right, guys. Go ahead and put that test away. You can work on corrections. Corrections to tests and quizzes are always due by the day of the next test. Cool. So you have until then. Get help from tutors. Get help from me. Do not find somebody who had the same version as you and just copy it. Okay. Definitely don't find somebody that has a different version from you. That has happened before. I'm like, your question is very different now. What the hell happened? Don't make it that easy for me. So, today we're getting into chapter 3. And this is really all about, the first section here is about like terms. Somebody help me out. Anybody know what like terms? We've already kind of seen them, to tell you honestly. But can somebody give me an example of like terms? And this isn't saying, like terms. This is terms that are somehow similar enough to do something better. I like it. So kind of a definition might be something that has the same variable in it. Right? So I could do this, 4x plus 2x, and of course that would have to be 6x. Why is that not, real quick, why is that not 6x squared?
You're not multiplying.
I love it. Exponents are based on multiplying. They will only change when you multiply. Coefficients are based on addition. They will change when you add and subtract. Cool. So if I try to do this, 4x plus 2y is 4x plus 2y. You can't do anything with that. Do not feel like you have to. If I say simplify and they give you this problem, you say it's already simplified. Or you just rewrite it. Like, Jeff, leave me alone. Give me something to do. Do not write 6xy. I don't see any xy's there. I don't see a single xy there. How did you suddenly get 6 of them? But you see what somebody thought, right? They try to throw them together. They're not sure what to put there, so they just put both of them there. Right? You guys kind of with me still? So where it gets a little freaky, you just get a little bit ahead of the book, is when I get something like this. Now they have the same variable, but here's the true full definition of a like term. It's got the same variables and the same amount of each variable. So these are not like terms. I cannot add these. I have 1x squared here. I have 1x there. I got nothing to do. Yes, sir? I love it. So if it was x squared plus x squared, well, how many x squares do I have now? 2. Not x to the 4th. I'm not multiplying, so exponents can't change. I'm just collecting how many x squares I got. I got a couple of them. There you go.
So if you multiply x squared plus x squared times x would be x cubed?
That's coming. That's not here yet. So when I multiply now, I can start changing the exponents. Because exponents keep track of how many multiplications I'm doing. Coefficients keep track of how many additions I'm doing. How we doing so far? We good? So now, on top of this, of course, comes in all of the sign number stuff. Because it could have a problem like that. Right? Of course, I've just had to go and take a big leap from what I was doing. First step is identify what you can actually work with. And are there any like terms up in there?
Yeah, just the y.
The y's. So I can work with this and this. So what's negative 7y's plus 3y's? So see, that's, you can't get away from it. The sign numbers, if you don't understand it now, you have to come see me, please. Because it will forever torment you. Because it's a part of everything. I'm trying to put things together. I've got to know how to deal with sign numbers. Negative 7 somethings plus 3 somethings is negative 4 of those things. And then I still have the... Oh, yeah, exactly. It's still a minus 2x hanging out. It's got nobody to go with. right, how you doing so far? Yes, sir.
It's, I don't know, it's the same if you just do negative 2x minus 4y.
Same thing, yes, exactly. So you can write it like that, you can write it like this. That old Beastie Boys song in my head all of a sudden. How we doing so far, mate? Decent? So some of you guys, I know this is old news. Just hang out, just enjoy the moment. For the rest of us, this is kind of like, okay, I kind of know what you're talking about, but I'm not really comfortable with this. So let me put up here a couple things here. You guys try these out.
Is that 7x or 7y?
That's an X there. Okay. So what happens on this first guy here?
You're going to do the a's first.
So here's kind of like what I do.
My turn.
I see, okay, there's W's here and here. There's A's here and here. So I kind of use a similar underlining. It kind of makes it easier to see them. You could rewrite them. I always try to show you ways to get away from that because that's kind of like lost time that you're not really doing something. Does that make sense? Every second is precious on a test. So if you kind of underline it real quick, 3W and 4W.
7W.
Negative 2A minus 9A.
Negative. I mean, minus 11.
I like it. Negative 11A. Cool. Right, so both negatives, so you add them, put the sign back on. So all I did in sign numbers does not suddenly go away just because we got out of that section. What about here?
The x's.
Yeah, the X's, this, and this. Anything else that's like terms?
The
The
number.
numbers are like terms. 2, negative 5. So we have, yes sir.
How do we know if there need to be subtract, because there's like subtraction and there's like addition and there's subtraction again. How do we know which one's
The
going to be?
2A is being subtracted.
No, in the bottom, like after you do the W and W and the A and A,
Yes.
then after that, how do you know if it's going to be the minus or the?
3W plus 4W. The sign in front goes with that thing. So if I were to rewrite this, here's the big thing. Here's a mistake everybody, where's a big mistake? Here's a mistake people make. When they move something, they leave the sign. No, that's connected. So if I move that 4W here, now it's 3W plus 4W. That plus came with, because the 4W is positive. You can't suddenly say it's minus. Well, Jeff, it's a minus sign there. No, that minus is with the 2A. That 4W is positive. That 2A is negative. So that's what you can do if you wanted to rewrite it. Which you might have to do if you're kind of not comfortable with this. It's been a long time. You might have to rewrite it so you can kind of focus on what's going on. Or hopefully we can underline it so our brains can see a little better. Whatever you got to do to make it work. And then you get 7W minus 11A like we got there. Does that make sense?
Yeah.
I'm glad you asked that question because that sign is connected to the thing right after. So that minus sign is not set in rock there, and you take the 2A and the 4W suddenly is minus. You can't, no. The 4W is positive. It can't suddenly become negative. Good. So here, I have 7x minus x is 6x.
9.
Plus 3x is 9x.
Minus
Is that cool?
Yeah.
Okay, and then of course 2 minus 5,
-3.
negative 3. Let me do that again.
Write it down the other way, right? -3 plus 9x.
Yes, exactly. The other way would work it also. You could also write, that's the same thing. As long as the 3 is negative and the 9 is positive, it works either way. Is there another question about that though? Do you guys see that? Okay. Yeah, can I do anything else? Are there any like terms left that I forgot? No, there's a bunch of x's collected here. There's a bunch of numbers collected there. They can't go together. 9x minus 3 is not 6 something, right? 6 what's? I've collected all I can. So that idea of combining like terms is collecting like things together. You can't go too far with that. Yes, sir.
But why is that one 9x if it's 7x plus 3x? Right? Oh.
Remember, there's always a 1 in front of just the number.
Yeah, if I have 7 x's and I subtract an x, now I get 6 x's, right? And if you need to, there's an understood 1 there, of course, yeah. So that minus x, just because it doesn't have a number in front of it explicitly doesn't not do something. It's subtracting an x. I should have 1 less x than I did, and then at the end I'm adding 3 more. Is that cool? Maybe. Okay. What about this last guy?
You just did the x's and that's
So
all.
y.
Yeah, what are the like terms here?
Just that.
3x and 2x.
Yeah,
Minus
these
3x.
x's are definitely like terms. Why are there no other like terms?
Because one's got exponents, the other y doesn't.
Yeah, one's got 2 y's, right? Y squared. And the other one's got only 1. They're not like terms. I can't combine those. You can't suddenly say I have 5y something. I don't have 5 of any y. I got 1 y squared and 4 y's. That's as collected as I can make it. You guys with me? Okay. So y squared
Minus 5.
minus 3 minus 2
Minus
-5.
5.
minus 5x plus 4y
Plus 7.
plus 7. You just collect everything else. They didn't have anybody to go with, so they stay the same. Yes, sir.
So you can't combine the y squared and the 4y?
I love it. Now, if you tried, what would it be?
2y.
If you try to put y squared plus 4y together.
I got 5y.
Now, if you say
I
5y
got
squared,
6y.
No, that's what I did.
and you got how much?
6.
You got 6y, okay. Now, for anybody who said 5y squared, looking in this, how many y squares do you see? I see 1 y squared. How can you suddenly say that there are 5 y squares? Do you start to see what I'm saying? I mean, this is just a question of being honest, really. I mean, I don't want to write x plus x plus x. I mean, that's insane. Just put those together. But you're not going to put them together with that and make it look like you have more x's than you do. Or you're not going to say suddenly 1, 2, 3, 4, 5 x squares. Now that's lying, right? You don't have 5 x squares. You have 1 of them. You guys, I mean, that's what like terms really is all about. It's being honest with what you got. So here I've got 1 y squared and 4 y's. I don't have 5 y squares. That 2 can't suddenly come down here, right? Those mean totally different things. Squaring something and doubling something, totally different. You can't suddenly decide to bring it down. So then you have like terms. You have what you got. You have what I've been given. We've been given 1 y squared and 4 y's. I can't put those together. Why? For a technical reason. This has only 1 y in it. This has 2. They're not like terms. Yes, sir?
Couldn't you multiply the y? Like, make it 2y? This isn't y squared, y times y?
Yes, I love it. Okay, y squared is y times y, which is not 2y. Definitely not. Because what's 2y? What's the coefficient mean? Those y's
2
would
times
be...
y.
Okay, I like it. 2 times y. But that would mean 2 y's adding, which is not the same as 2 y's multiplying. If exponents and coefficients were the same thing, why would we have both of them? Right? And you're all like, well, because math doesn't make any sense. No, yes, it does. It desperately does. Right? Yes, sir.
Is it not necessary to write in order, as in the variable with the power, then the variable?
That's coming.
Oh,
We're not quite there yet, and actually I'm throwing a little bit, by bringing these squares in here, I think I'm doing it a little more than the book does, actually. Let me see if that's true. Yes. In the book, you're not going to see squares on anything. I'm trying to show you a little bit more complete picture. If you're able to understand this, you should be able to handle the book. The book's just going to give you a 5A plus B plus C plus 2A, and you just put the A's together. Right? That should be, compared to this, it should be a lot easier. This is in our very near future, though. It's the same idea. It's this idea of like terms. Okay, so how do you guys feel? Any more questions on that? So let me show you the next level. And you know, I completely understand that some of you guys right now are like, okay, you're making a little bit of sense, but why the freaking hell? Probably use a different word here. Are we just playing around with 4x and 2x make 6x? It's nice to play around if I had all day. I got other shit to do, Jeff. But because in the real world we have, you know, like I could have the cost of something and the revenue from something. And the cost of something is going to be some big equation, and the revenue is going to be some big equation. If I subtract these two things, I get my profit. If I'm not able to combine like terms, I'm going to have this ginormous frickin' equation and then I show my butt. No, screw that. I want to put my like terms together because I got to use that equation over and over and over to do stuff. So I need to know how to combine like terms so I have a much simpler thing to look at. Right? You guys kind of with me? I mean, combining like terms is almost like learning the grammar of putting sentences together. I need to be able to put stuff together to have something easier to work with. So here's the next level. Go to a whole another level. No, too old. Somebody got my reference? All right, so nothing major there, right? I've added one other thing to do. Yes, ma'am.
Is it still,
Yep. What do I need to do?
2 times x.
All right, that's a good first step.
2x.
negative 14?
For some reason, I get somebody give me 8x at the end. You see why they would give me 8x? Where's that 2? How far can that 2 go? The parentheses are often called grouping symbols because they group stuff together. So I've grouped those together so I can double them. That plus 4x is way over there. That 2 can't jump way the hell over there. You with me? So this is called what? Distributing. I love it. So there's a math word that actually makes sense. I distribute the 2 to everybody in the parentheses. And I still have that plus 4x there. So all I did was rewrite this as this. Woohoo, Jeff. But now that I've done that, I freed my x's up. What can I do with them now? Yeah, there's a 2x, there's a 4x, so 6x,
Negative 14.
and the minus 14 is just by himself. Okay, cool. All right. So you guys try this one. Being a little bit evil here. Let's see who's careful. All right. So what's my first step on this? Good. Bring the 7 through. Each thing in the parentheses, so I get 7.
70. 14.
This poor thing's dead. 7A minus 14B
28.
plus 28C. Good.
Minus 2A.
Plus 6.
8.
Good. Yeah, it's an A. Sorry. Minus 2A plus 6C. I love it. I didn't hear anybody say minus 6C. That minus 2, minus 3 makes plus 6 when you multiply. So you got to distribute that negative with it. So be real careful about that. That screws everybody up. I don't care what level of math you're in. Somewhere somebody makes that mistake. Right? Me included. It's a very simple mistake to make. And now what can you combine? Yeah, the A's
And C.
and the C's and the 4 B's. They're left out. So 7A minus 2A,
5A.
5A. My 14 B's are left alone, poor little dudes. And then 28C plus 6C.
22C. Oh,
44.
So negative 2 times negative 3 plus 6. Cool. So 28 plus 6, 34. Cool. And you have to admit, that does look better than that. I know it doesn't look good, but that does look better than that. So you can imagine it's not too far from there to think about this huge thing of stuff that somebody has put together. I want to put it together so I got a smaller thing to look at, to work with. Yeah.
Now, could you, the negative 14b, could that be at the,
Yes, it could be. In general, though, I think there was one question about, you normally, if there's powers, you normally have the highest power and then you go down to the lowest power. More generally, it is convention to put them in alphabetical order also. But, you know, this is not, I'm not going to check your alphabetical ordering. But if you put the minus 14b at the end, I love it. And it's not a bad, because that's, you normally think like terms, and then what's left over. That's cool. Nothing wrong with that. All right, so it's not too ground shaking there, right? I mean, that's, you got to distribute, you got to be careful with negatives, and you got to understand what like terms means. Now, the reason we're doing this whole section, that whole section has nothing to do with solving equations. It's just combining like terms, because what happens in equations, I have like terms to combine. So let me give you this. I'm going to unleash you on this problem. Try this out. It's going to be relatively ugly. You guys can do it. I know. Now, there are certain things I have not really told you about yet. This is a lot worse of an equation than we've seen so far. I am taking a big step right now, but I just want to let you just give you a chance. If you get it wrong, who cares? I will never know unless you just come up and show me your bait. Give it a try. Try to see what you are able to do. You're allowed to play with this thing. Just to give you a little clue, if you're not sure where to start, look at a single side. Doesn't that look a lot like the stuff we were just now doing? So you probably want to attack that the same way.
yes or no answer? Like, is it equal to?
No, it's not a yes or no
So
answer.
sub was the number.
Yes. You just get an answer at the end. and don't feel pressure. There's no pressure here at all. Just see what, from what we just discussed, what can you attempt with this thing? No need to feel like, oh, I have no idea, oh shit.
Could actually do that. I think it was right 10, the right way. If there was a 2x, what would you do with 2? Divide by 9. That makes it negative. Close. Oh, just be careful. Negative. They're both negative. Debt, more debt, yeah. I like it. Some of you guys look like you want to hurt me, and I'm like, what the hell, man? Nothing major here. Close. Almost. What happens? Oh, okay. Cool, you're right. No, I was some other guy. Oh, from the very beginning, be careful. Very, very first step. 4 times 2. Take that amount. White. I see where they came from. It's almost the right idea, but you lost your equal sign. You lost your 2 sides. Okay. All right, let's take a look here. Some guys over here, you might have a negative in the wrong place. No, that's my fault for not catching it. What do you do when you first start this problem? What do you draw into?
There's 2 different sides.
Okay, good. One thing to realize is there's 2 different sides here. There's this side I want to work with, and there's this side I want to work with. So it's like 2 of those problems in one. All right, so the equal sign naturally breaks it up into 2 sides. What can I do on this side?
Distribute the
Yeah, your
forward.
eyes are always drawn to those parentheses, just like order operations tells you to kind of start there, right? Of course, here I can't do this inside, can I? Why can I not do 2 minus 3x? They're not like terms. So you do not tell me that's negative x. Do not tell me that kind of thing. Right, because it ain't. You got to bring that 4 through. What do you get? 8 minus 12x plus 10x. Good. So that's that side. I can distribute there. Same thing over here.
Minus 2, minus 3x.
All right. Now let me really emphasize this point. A lot of you guys do poorly with equations because you aren't organized with what you're doing. And this is what I was saying earlier. Some people try to do parts of an equation and then the other parts, and they try to bring it back together, and you forgot where it was where. Good Lord. Replace this with what it is. That's there. That's there. Replace this with what it is. That's there. Right? Continue. You have to be very organized so you don't lose anybody or forget where they were. Things suddenly start to move to the other side somehow. They tunnel underneath. I don't know what the hell they do. What can I do on this side still?
8 minus 12x.
No.
2x.
Yeah, what's like terms here?
12x and 10x.
Yeah, the negative 12x and the 10x. So negative 12 plus 10,
2x.
negative 2x is 11.
And then do the x's on the other side.
So negative 12x's plus 10x's. Negative 12 plus 10 is negative 2 x's. So if I have negative 12 x's and I add 10 x's, I have just negative 2 x's left.
Oh, so you're just adding the X.
Yes, adding, I've got 10 of them here, negative 12 of them there, so I'm left with negative 2 of
Okay.
Good. Yes, exactly. And over here, what's like terms? The x's. So I get 2x minus 3x. Negative 1x, good? And then minus 2 is still there? Yes, sir?
Just when you bring x's together, right?
Yeah. And personally, it doesn't matter which side the x's go to. They just have to be by themselves. And it's not a bad idea to always make sure the x comes out positive. So I could either add x. Why would I add it? Because right now it's negative. I have to add it to make it go away, right?
Right.
But then this would be still negative on this side. So I would say let's add 2x to both sides. And one thing I noticed on the bonus problems is a few of you guys attempted it. Make sure what you do actually makes the other thing disappear. I saw a lot of this kind of thing. Do those go away? No, it becomes even more negative x's. Who wants that? I want them to go away. Make sure what you do makes it go away. Yes, sir?
Right there in the bottom, how do you get 8 minus 2x?
Because what's negative 12x plus 10x?
Oh, so the 8 you're looking with again?
Does it have anybody to go with?
No.
No.
So you do the x.
So the 8 comes down, and I rewrite what this really is. Negative 12x plus 10x is better known as negative 2x. Did the same thing on the other side. Those two made that, and the minus 2 is still there. So now I'm going to add 2x. Why am I doing that? Because I don't want x's on both sides. I want them to die on one side and basically show up on the other side. So here on this side, what do I have left? 8 equals,
Okay. Minus 2.
yeah, negative x plus 2x is a positive x. I love it. You with me?
Yeah.
Negative 1 of something plus 2 of something is positive 1 of that thing. Yes, sir.
All right, so what if you added x to both sides?
You have a negative.
You would have a negative x here. You would not be wrong.
8 minus 3x equals negative 2.
Now I'll show you. I'll show you what it would look like.
That'd be-
It still leads to the right answer. It still leads to the right answer. It's just you have a negative in there that might trip you up. Which I think tripped up a few people over here. And then the last step, why is the x not by itself yet?
We need to get rid of the 2.
Yeah, there's a minus 2, so I have to do what?
Plus
That's
2.
2.
I always think about what's going to make that thing I don't want go away. The x is still here.
Equals 10.
8 and 2 is 10. Cool.
Win.
Yes, ma'am.
Positive 2 with the x. Why the x is still there?
Because if I have, so here's the big mistake I see. I'm glad you're saying that. The big mistake I see is somebody, what just happened? The big mistake I see is somebody tells me the answer there is 2. Can you see why they would think that?
It's number 2. There's some
Because they have 2x and they take away the x should be gone, Jeff. And I understand the reasoning there, but it's not correct. If you look at what is 2x really? X plus x. So if I have 2x minus x, I have x plus x minus x. So what happens? You lose an x, don't you? So what's left? Yeah. So if I have 2 x's, and I take 1 x away, I still have 1x. Now here's a more interesting question. If you wanted to if you wanted the x to go away, what would I have to do? If I wanted to make the x go away, I'd have to divide by x. Let's not go there. I don't like variables on the bottom of things. Let's not go there. If you wanted for some reason to make the x go away, you'd have to divide. Why? Because what's the operation right now? Multiplication, exactly. Right? So you can't make that variable go away by adding or subtracting. You can't. You can only change how much of it you got. You have 7 x's and you take 5 away, you still got 2 x's. You can't make the x go away. So let's dial it back a step. I just wanted to throw at you a problem that's actually uglier than any problem you'll see in this next section. We sort of got into section, well, at the end of section 3.1 actually. Into 3.2.
Can you work with the problem, put in the 10 instead of the x? To see if it makes
Oh yeah, sure. Oh, to check it?
Yeah, because
Oh,
I
hell
was
yeah.
doing that and now I'm confused.
Gotcha. So if you want to check this, which you can always do with any equation in any class that you ever take in math. You can always check the answer you get. Plug the 10 back in. This gets a little bit ugly. Plug the 10 back in. Everywhere I see an X, I got to plug a 10. Kind of ran out of room here. Let's see if I can squeeze it. 2 times 10 minus 1 is 9. Is that cool? 3 times 10 is 30. Okay. Yeah, a little bit of license there. And this, you can check your work. You have to plug it in to the original equation. Why is that? That's a much easier equation. Why don't I just plug it in there? Because you've done a couple. You've done. That's the new way to do a past tense. You've done a couple things. That's what I'm trying to say. You've done a couple things. Maybe you made a mistake on the very first step. So to check your work, you always got to put it back in the original equation. I know that that's the easier equation, but you might have made a mistake. Plug it in the original. So if you do this work, 2 minus 30 is negative 28. 10 times 10 is 100. On this side, I get 18 minus 30. I'm just going to kind of do this a little fast. Is that all right? Because when you're checking your work, you can certainly use a calculator to check your work. There's nothing wrong with that. 4 times negative 28 is negative 112, I think. Yes. Plus 100, that does equal negative 12. So you can check it, and it comes out true. Thank God.
Oh, I see.
You can see how the checking, actually, if you try to do it by hand, the checking itself could be somewhere where you make a mistake, and then you're not sure. Did I make a mistake in my check work, or is that actually wrong? Oh, shit. All right. Yes, sir.
So the check won't always come up with the answer that you get for
Careful.
X, but they're equal.
I like it. Here's my answer for X, right? That's what I plug in for X. The numbers I get at the end, I got negative 12 equals negative 12. That has nothing to do with the number 10, except the fact that it comes up with a true statement. So therefore, my claim is, you guys are all looking in my direction still, I like that. My claim is that when this is true, this is true. So how do I check it? I make X equal to 10. I make that true. I plug a 10 in, and then I see if I come out with a true statement. Yes, I do. So this number has nothing. You don't go, oh crap, the answer is negative 12. Oops. No, the answer is 10 because that's what makes that true. Sweet. I like it. Thank you. Cool. Bless you.
Thank you.
Oh, is it bothering you? I'm sorry. I think I felt that. So let's take a step back and let's look at the actual problems you'll see. You ever have shoes where you gotta like tie them twice? You gotta tie your little loops together? All right, now I feel like I'm Mr. Rogers.
Wait, I do have a sweater.
Yeah, I know. Won't you be?
You just said the way to get rid of, like, on the other board, you said the way to get rid of 2x is you had to divide by, you had to get rid of the, oh, you just to get rid of the x, not to get rid of the number.
Exactly.
Okay.
Because you can't make the x go away by 2x minus x. You would have to divide to get rid of it because it's multiplying.
Then how did we get rid of the 2x by adding?
No, I got rid of the 2x. I didn't get rid of just the x. I got rid of
you
the
just
whole
want to get rid of
thing
the x period.
by
Okay.
adding its opposite.
Okay,
Cool, okay.
Got
That's
it.
simple. All right. So, let's take a step back. Let me give you some problems like what you'll actually see. Which would be just a little bit better, a little bit easier than what I threw up here. Here, you guys try these two out. I think you agree that those two are definitely not quite as ugly as that. The same exact idea. There's just a fewer steps because there's less stuff. Yeah, there's no parentheses, so there's no distributing to. Everything's free. So what's wrong with this equation? Your goal is x equals a number. So what's basically wrong with this is I have a mixture of x's and numbers on both sides. I got to get my x's on one side and my numbers on the other side. I got to keep those separated. So are there some x's? Here's some x's. There's some x's. Can you get those to cancel on this side? Can you get rid of those x's so it's just a number on that side? What would you do to make the 2x go away? How would you cancel the 2x so it comes out to be 0? What would you do to make those 2x's go away? Yeah. Negative 2x. Subtract the 2x from both. Whatever you do to one side, you have to do to the other side. So right underneath, you put in minus 2x, minus 2x. Exactly. And then write what you have so far.
And I leave those other two numbers.
Everything else stays right where they are. Exactly. Keep it organized like that. You won't lose anything. What would make that cancel? If you add 2x, like if I need to make it go away, so subtract 2x. Reach that. One more step. The x is not going by itself. You gotta get that 2 away. How would you kill that 2? How would you cancel that 2? Because what's the operation right now? 2 what x? What are they doing? What operation are they doing? Are they adding? They're multiplying. So how do you undo multiplication? Divide. So right here, what is 2x is minus 2x. That was your whole point, was to try to kill that. So that there's just a number left there. So now over here, you got all your x's together. Are your numbers together? These guys want to go over there. So how do you make these go away? How do you make those cancel? Right now it's minus 7, so how do you make it cancel? Over the opposite operation. What would you do to make the minus 7 become 0? Make it cancel. That would make it more negative. What's the opposite of subtraction? Addition. So if you add 7 to both sides, negative 7 plus 7 would go away. And you put 7 over there also? Yep, because that's what you're doing to both sides. You're plus 7. You're adding 7 to both sides. 18. So equals 18. And then there's actually one last step. Hold on. So, real quick, guys. I want to show you something. All right, here. This is going to be amazing. 3 equals 3. Now, and that's true, right? In order to keep this to be a true statement, I want to keep the truth of this statement. If I add 1 to this side, I have to add 1 to that side. So the classic example is have a picture of scales in your brain, and I sort of don't like it, but it works. If I add 1 little gram on this side, I better add 1 gram to that side, or else Indiana Jones gets chased by the big boulder. So that's the idea here. So what makes it just a little more interesting is you can create your own equation. Give me a number. 4. Okay. Now, what happens if I add 1 to both sides? Here I get, and what's x plus 1? Come on now. I love it. What's x plus 1? X plus 1. Are they like terms? No. If you say 1x, you have somehow made addition become multiplication, which is neat. It's a really cool trick. It doesn't work. Now think about it. If x was 4, isn't x plus 1 5? You kind of with me? Now what happens if I double both sides? Double this side. What will I get on that side? Now just take a second. Isn't that an equation you could certainly see in this? Well, how do you solve it? You start undoing everything somebody else did. You kind of with me? The whole point of this is to strip away all the stuff some other jackass did to us. They started off with, okay, x is 4, and then they added all this other crap on top. We're like, oh crap, let's kill the 2, let's divide by 2, let's subtract the 1 out of there. Shit, I gotta get this x dug out of there so I can see what the hell it is. So that's the whole idea here. Now, what's added on top for us now is the fact that this was still kind of nice because there's an x just on one side. Over there I've got x on both sides, right? But what keeps you focused is your goal. You want x equals number. That's your goal. So that goal tells you I want all my x's on one side, which means I want one side to have no x's, and I want the other side to have no numbers. So I have only x's and only numbers. You with me? Sort of? I mean, that's the goal. Because then if I get there, x is that cool. I know what x is. I'm done. Right? That's the point of this little game, is to figure out what x is. So the problem then is I have x's on both sides. I want to make them go away on one side, effectively showing up on the other side because I have to do the same thing to both sides. So a lot of people think when I want to move something to another side, I just do the opposite of that thing, and it shows up on the other side. How do I make those two x's go away? Subtract them. How do I know to subtract them? Because 2x is currently positive, adding with the 11. So the opposite operation would be subtraction. Whatever I do to one side, I must do the other side, or else it's not true anymore. Right? If I have 3 equals 3, and I add 1 to one side, it's not true anymore. Okay, cool. So then here I get 2x. That was nice. I think we need musical intermissions in math. I do. The 2x's, what happens here? Be careful. Yeah, 2x minus 2x is 0. Let them go away. The whole point of what we did was to make the x's go away over there. Let them go away. Right? Equals 11. Good. You can put the plus sign, but now we don't really need it. Now, one good thing we did was we got all our x's. All of our x's are now there. What's still wrong is our numbers are not together. So where do I not want them to be? I don't want them to be here with these. I want them to be alone. They're very antisocial. So what I have to do with that minus 7? I got to do whatever's going to make it go away, which is adding. So I get 2x. Those go away like I wanted to. Equals 18. And the last thing, the x is not quite by itself yet. Why not? Stupid 2, right? Call it stupid. What's the operation?
You divide it by 2.
It's currently multiplication, so you must do the opposite. The most common mistake is I see that. And I can't necessarily blame you too much. That's your brain hijacking things. You got to stop your brain. Say, brain, stop. Can't subtract that 2 because it's multiplying. I got to do the opposite. I got to divide. So then I get x equals 9. Cool.
And then if you do it the other way around, you get the same answer.
The other way around.
If you subtract minus 4x.
Exactly. You just get, at the end, you'll get negative x equals negative 9, and then you divide by negative to make it. Yeah.
Right.
Exactly. Cool. There's more than one way to do this. X is on one side, numbers on the other side. I didn't say which side. They don't have to be on a certain side. Either way. So I don't know if anybody else subtracted 4x over here. Anybody else do that?
I did both.
You did that? Did you come out the same at the end?
I just redid it and did it with the
Shit. Let's do it that way, because it's got to work the other way too.
Yeah.
Both negative, yeah.
I don't want to come away from here making you feel like you did something wrong. You didn't do a damn thing wrong. Well, somewhere you did, but the approach you took wasn't wrong. So just figure out what went wrong in the middle. So that's done, but let's try it a different way. Let's subtract the 4x instead. So if I subtract the 4x, so I made those go away here.
Right.
That's still here. What's 2x's minus 4x's?
Negative 2x.
Guys, negative 2x. That plus 11 is still here.
That's 7.
Good. I got all my x's together. I need those numbers to go the hell away.
But
Good.
try-
Subtract, because right now they're positive.
minus 18. Negative 2x. 0.
So your last step, you don't want what?
Negative.
The negative 2. So what do you do with it?
Divide.
Divide, because it's
Negative
right now multiplying. So you get x equals,
9.
good, because the negatives go away, and 18 divided by 2 is 9. Either way you do it, you should get 9. Which?
No, that's
This way? Because you don't get those negatives. You don't need to get those negatives. So if you think about it, you can always go the way that you're not going to get some negative coefficient on your x. That's one less place to make a mistake. Which is all. If you got an option, I think I go that way. I'll go the route that I make less mistakes. All right? All right. This guy. What's the first step?
Distribute.
Distribute. Right. So you get
3x minus 3.
good. And I can't make this point enough. I always get somebody that the equal sign goes away somewhere, and then you bring it back somewhere random. You just plug it in between something, or everything's on one side or something. It can't work like that, right? So I'll get somebody who, let me show you this. If I show you this, maybe it won't happen. Like, right at this step, they'll do this. And the equal sign is gone. You guys kind of with me? Do you see what happened here? Then divide by 2 and suddenly get x equals -9, which is not the right answer. So what the hell happened there? They went the wrong way. And they lost their equals, and then suddenly it comes up out of nowhere. Like, what the hell? So what really should happen is right here, this should have been equals 0. Then you see how you've loaded one poor side down with stuff. I want to get x's one side and over this. So don't lose stuff on the way and then try to just, oh yeah, the equal sign, let me bring that back. Okay, cool. So here, what can I do on this side?
At the end.
Yeah, the 3x plus x,
4x.
4x. Everything else is in the same place, right? The -3 is there, the equals 2.
Wait, what?
3x plus x is 4x. And everything else is still there. The -3 is there, the equals, and the 2 is still there. Everything is still there. Cool.
Oh, it's, you just added that.
Yeah, all I did was put those together. I haven't done anything to both sides yet. But what am I going to do now to both sides?
Get rid of the 3.
Get rid of the -3, so I have to
Left 3.
add 3. I love it. Both sides. Cool.
Yeah.
4x.
Good, so those go away. I get 4x
5.
equals 5. And this might be where some of you guys freaked out a little bit. The most, I was going to say the most best place, but the best place to get a fraction is at the end of a problem, because then you're done. So I will get a fraction here.
Yes.
And who cares? So I got 4x equals 5. What's the last step?
Divided.
Divided by
4.
4. The biggest mistake is I see for some reason people divide by 5. I'm like, why would you mess with the poor 5 dude? He's fine. It's the 4 that you don't want. So you get x is 5/4. Fraction, oh shit, no, you don't care. You've done circling. Where you would care is if I said check your answer. I'm not going to do that to you with a fractional answer yet, because we're officially not yet in fractions. Right? That's coming up later. So just to give you an idea of the layout of this course, we're talking about basics of solving equations. When we talk about fractions, we'll have equations with fractions in them. When we talk about decimals, we'll have equations with decimals in them. You see the idea? So throughout the semester, it's kind of infused with equations. We'll introduce a topic. Here's an equation with that stuff in it. Cool.
Is it possible to get 1 whole and 1/4?
Yes, sir. You could say, or, you know, that's just rewriting it in a different form. It's the same answer, yeah. Either way you look at it, it's 1.25. All right, how are we doing? Okay? Again, some of you vaguely look like you want to kill me. I never know how to take that.
I forgot to eat breakfast, so I don't want to kill you. I'm just hungry.
Oh, I see.
She wants to kill you.
You just need to be fed. I understand. All right. And I'm going to give us an early day. What the hell? Is that all right?
I'm okay with that.
You okay with that? Some people aren't paying attention. I love it. They don't realize I'm letting them out. They still don't. We just to make sure you understand, we've actually sort of just did 3-1 through 3-3. Because 3-3 is kind of a combination of everything at once. So we've basically done 3-1 through 3-3. All right, guys. So